Section 4 for Chapter 1 called Powers and Monomials, and this is for Math 8. So just to kind of introduce again at the beginning of each of these videos, this is the teacher preview, so when you're doing your homework, you will also see a due date here. I don't see a due date because it doesn't give me that for the teacher preview. You always have unlimited retakes, so we let you go in and take it as many times as you would like. This will tell you how many questions are on the assignment. In this one, there's only 5 questions. You always get the best score, so every time you go in and you answer another question correctly, it's always going to give you the best score out of all of your attempts. Partial credit just, literally means if you answer 1 of 5 questions, you get credit for that 1 question. And as always, once you start an assignment, so once we click the start button here, you always want to finish it. And what that means is you want to click the submit assignment button that's in the bottom right corner for students. It's not on the teacher side here, so you actually won't see that on this recording, but on your screen, you will see the submit assignment button. All right, so let's go ahead and get started here. And always when you're opening these assignments, and this is only for the homework portion, but for these homework pieces, when you see this way, you'll see the little glasses. That's an explanation. It'll explain this exact problem. This example will give you just another example, If you click explanation, it will actually take the attempt away, so you won't then be able to answer the question it just gave you the answer to. You'll have to come back in and try another one. But example just gives you a separate screen with an example on it, and then the message center here. So you can send a message to your teacher with this question attached. Okay, so let's go ahead and get started here. On this one, we're looking at power of a power. That's what this is called. So remember, a power is written like this. This is a power. And what that means is it has a base and an exponent. Okay? So we have our base and we have our exponent. And so we call this whole thing together a power. Well, we're saying it's a power of a power because now we're taking this power that I just explained and we're raising it to another exponent. So it's a power of a power. Sorry, power of a power. I kind of circled those wrong with my mouse. But so what we were learning on the previous section is that what this means is 4 to the 5th power does not mean 4 times 5. It means I'm using 4 5 times. So it would actually mean that I would write it this way, like this. 1, 2, 3, 4, 5. This is what 4 to the 5th power means. And what this 7 on the outside means is that I'm doing this piece 7 times. So I'd actually have to write this out 7 more times, which seems like a whole lot of 4s. And, that is going to be a lot of them. So instead of doing it that way, what I wanted to show you is you can use multiplication. Because if I know I'm going to go 4 to the 5th power, 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 4 to the 5th power. Let's see, 1, 2, 3, 6, one more, 7. So here we go. Here are my 7 4 to the 5th powers. That's what this power of a power means, okay? Remember, each one of these has 5 4s in it. So I'm just writing the exponent down because what we learned last time is I can add these together. So I can bring all these 5s down and I can add them together. So I'd have 5, 10, 15, 20, 25, 30. Oop, am I missing one? 1, 2, 3, 4, 5, 6. I missed one somewhere in here. 6. Oh, nope, I just didn't write down 7. I counted them wrong to begin with. So we'll add that 7th one in there just to make sure I have it. So 35. So I know I have 35. If I were to expand this out, I would have 35 4s. We're getting to that point where it's going to be not just tedious, meaning, a little bit time-consuming and kind of boring to write down all of those numbers, but we're also getting to that point where we're going to start having mistakes if we try to expand this out all the time. Because now, even just doing this with 7 of them, you can see I counted and I thought I had counted 7. Well, I had only counted 6 of them. And I had to add another one on there when I realized I had counted incorrectly. So it's just one of those things. The bigger we get with our problems, the more we want to find kind of the simpler way to do it so we don't have to write down quite so much. The more we write down, the more room there is for error. Not that we don't want you to show your work. That is in no way what I'm saying. We definitely want to see your work, but we don't want to cause more errors if there's an easier way to do this. Okay, so I have 4 to the 35th power. That's what this answer is going to end up being. That's what we're going to rewrite it as. But if we notice, if you go back and you say, well, what's 5 times 7? Oh, that's 35. And that is actually our power of a power rule. Instead of having to expand it out like this and then also write out all the 5s, we can just say, as long as I have the parentheses here where it's a power and a power, or an exponent and exponent, I'll say that the correct way, then we can just multiply them together and you get 4 to the 35th power. So 4 to the 35th, and let's check that guy. Cool beans. Next. Okay, so let's go ahead and practice this a little bit. It says write without exponents. So remember what that means is they want me to kind of write it like this, but even further, they don't want any even 4 to the 5th power on this one. So I have b squared, and then that's cubed. So remember that would be b squared, b squared, b squared. Oops, I wrote a 3 there. I said squared. So here's my 3 b squares. Remember this, it's saying use this whole thing 3 times. So now, because it wants it without exponents, I need to show all of the pieces. So here's my first b squared, my second b squared, my third b squared. Remember, there's a multiplication sign in between all of these. So it's all being multiplied. So now I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. Okay, I counted that a few times just to make sure I didn't mess that up. So now down here, how many b's did we have? 6 of them. But again, if we understand, 2 times 3 would have also gotten us 6. So we don't always have to expand that out. And this one's not too bad. This one's pretty simple to expand out. But this other one, that very first one we did was a very good example of, well, I'm having to write down 35 of them if I expand it all the way like this. So just, we definitely want to be paying attention to those rules and how the kind of easier way to get this problem done. We do want to understand how and why. So it's definitely important we understand this expansion and how we get the 35 in this first one and how we got the 6 in the second one. But just making sure that we understand kind of, oh, no, I wanted to click on that. I just wanted a new flip book real quick. Okay, so let's go ahead and practice the second one. So again, we have v to the 4th to the 4th. So if we use our rules, and it just says without parentheses, so that means they just want us to do this power of a power rule. So 4 times 4 is 16. So remember, I would have written v to the 4th 4 times, and each one of those has a 4. So 4 plus 4 plus 4 plus 4 is 16. It's the exact same idea. It's just a more efficient way to do it so there's less mistakes. All right, we are going to do one more, or no, 2 more. Sorry, that was number 3. We're going to go to number 4 and then number 5. Okay, so with this one, we want to be a little careful with it because when we have the exponent out like this, we have to make sure we're distributing that exponent to everything. So I have a lot of students who will just do it to the variable right next to it here. It also goes to the coefficient. So it's 5 squared, and it's going to be the y squared. And if there was a variable here, or not a variable, sorry, an exponent here, we would have had to multiply those two. But really it's a 1. 1 times 2, we end up getting 2 there. But we want to make sure that we simplify this also, because they don't want us to type in 5 squared. They're going to want to say, what is 5 squared? It's 5 times 5, which is 25. And then we have the y squared next to it. So 25. Oop, I forgot my y. Y squared. Check. All right, we are trucking along here. One more. Okay, so we have negative 2b a to the fourth power to the fourth power. So remember, we want to give this 4 to everything, not just this one next to it. We're basically distributing it to everything. That's the idea here. So it's negative 2 to the fourth power, b to the fourth power. Remember, that's got a 1 there, so 1 times 4 gave us 4. And then a to the fourth power raised to the fourth power. So remember, it's 4 times 4. In this case, it would be 1 times 4, so that's really just going to come down to 1. All right, so with this one, remember, it's negative 2, negative 2, negative 2. So the reason I'm expanding this is to be a little dramatic about the negatives. Be careful about your negatives. Negative 2 times negative 2, that's a positive 4. 2 negatives make a positive. Negative 4 times negative 2, positive 4 times negative 2. I don't know why I threw a negative on there again. That's going to be a negative 8 because it's a positive times a negative. Negative 8 times negative 2. Negative times a negative gives us a positive. 8 times 2 is 16. So it's going to be 16 for our coefficient now. B, remember, this is just 1 times 4, so it's going to be b to the fourth power. And then a is going to be 4 times 4, which is 16. So we end up with two different 16s there, but they definitely mean different things. So we have a to the 16th power. And I like to put them in alphabetical order. If you notice, I just switched a and b. Oh, why is it doing that? I want another one. Oh, I guess I have to type in the b first before it does it. There we go. And I got rid of my 1. Interesting. Okay, so, and I just switched around a and b here when I typed it in. It wouldn't be wrong if you typed it in exactly like this. 16, b to the fourth, a to the 16th. It should take it this way as well. I just like to write them in alphabetical order because it's kind of the proper way to write it, to make sure that they're, when we start having like terms, if you always put them in alphabetical order, they're much easier to identify. So I always do alphabetical order, and then if we aren't going to have more than one variable that we have to worry about with different exponents, because we're not necessarily dealing with that level of math yet. So just worry about, alphabetical order for now. But again, if you typed it in this way, would not be wrong. It might give you an error as far as, they should be in alphabetical order. All right, I'm going to go ahead and click check. And we should be good to go. Yay. All right, that was section 4. I will see you in section 5.